Hi, I'm Christopher Lewis Saint, and this is for lab 3 for the class EEE 120 Digital Design. I'd like to show off this circuit first. Where, as you can see, this 4-bit register is made up of 4 registers which stores 1 bit each, and this whole circuit is able to store up to 4 bits of information at once, with the enable output enabling where you can store it and the clock helping timing it to prevent racing conditions. And the reset resets it all to 0. And this is the waveform for the 4-bit register. And this is the incrementer, which increments a value, which counts up from 0. And this is our program counter, which counts from 0 and goes upward. And this is the program RAM, which is used to store the instructions of our data. It can also be modified with the rank being up 1. And the RAM is like a neighborhood where each house stores data, and each house has its own address, thus the address line. And the data in is used to modify it. This is used to modify the data, and the data out is the output. And this is the brainless CPU, where the ALU takes care of the 4 operations and not negations, plus subtraction and addition. And the output is stored in the output is stored in the accumulator. And the accumulator mux determines what the data bus stores, whether that's the accumulator or the result of the data mux line. And the data multiplexer chooses between the data in, either the data in or the program RAM, with read being 1, reads from the program RAM, else 0. And for the and accumulated to dB, if this is 1, then the data bus will read from the accumulator. 0, it won't read from the accumulator, read from the data mux. The accumulator mux on 1, the accumulator mux reads from the accumulator, and 0, it reads from the data multiplexer. And the load accumulator is put to 1 so the accumulator can store data. The read is used to read from the RAM, and the write is used to write to the RAM. The data in is the input, the address bus is the address, invert, arithmetic is for addition, subtraction, and pass is let the A value pass through into the accumulator. And this is clock being clock. And this is the waves for the operation 3 plus 5. And the result is 8, as it should be. And this waveform shows the test of storing 3 from the data in line directly to the RAM at address 0, which is then projected into the data bus as 3. For this test, we write from the data bus rewrite from the data bus. Rewrite from the not the data bus. Rewrite from RAM. Rewrite from the data in to the accumulator to the RAM directly to the RAM. And to repeat again, in case someone missed it, this test is restored from the data in to the accumulator to the RAM as showcased with this waveform. And for the final waveform, this first to put 3 in the accumulator and then 3 and 5. We do the bitwise operation of 5, which results in 1, and then we invert the 1 to get a 0.